Alright, take the derivative of x in relation to y. When you say in relation, what do you mean? Like,
dy over dx.
so that would be the derivative of y with respect to x.
Oh, sure.
You would want to say that there. Find tangent lines on circular functions. Very good. I would also add something to the effect of, like, apply the chain rule when differentiating y. Most of the time you can use y to represent the result of a function we call y prime. Go ahead and make that, like what you can do is go in here and make that an equation. Go to insert equation, make that an equation. Also be written as dy dx. Occasionally the y value is implicitly stated to be a function of x, for example, in a situation where both x and y are on the same side of an equation. Like this. Go ahead and center this. This is the equation of a circle, but how can one find the derivative at a point on a circle? We will have to directly derive y. I would also graph this, by the way. Take the derivative with respect to x on both sides. Context y prime. Make that an equation right there as the derivative of, insert equation. This is the derivative of y and represents that the function has been derived. It's essentially the same as f prime. Is that f prime of x there? Yeah, make that do an insert equation on that guy too. Just to isolate y prime. Just go ahead and center this guy. Oh, also make him an equation. Insert equation. Okay, the problem with this is that this circle here is not the same as this one right here.
It's just like
this. So what I would do is make a graph of this, maybe in Desmos or something, and then do it again over here, and then show the point right there, or something like that. I don't know, because the radius on this guy will be 5, right? Because r squared. This radius is 3. So, but you have a good start here. What I would say, the reason why this is important for implicit differentiation is what you should start with is you should start with the equation of the circle and then ask the person to find the slope when x is like 3 or something. And then what you want to say is, well, what's the problem with finding the slope when x is 3? There are actually 2 places here where x is 3. There are 2 different y values. So which one do we want? Implicit differentiation lets us figure out the slope at any point given the x and the y value. Like, that's why it's so important. So this is really good though, what you have here. All right, here's a function slightly more complex than the circle. This is not a function. I highly doubt that it's a function, although we can check real quick. I'm gonna guess it's probably not. It's probably a relation. Come on, internet.
there is a possibility that it might or might not be an equation.
It's definitely an equation. There's definitely an equation going on here. Oh, my internet's not working. Would help if I had working internet. Still not working. Oh, here we go. Wow. Let's just graph this guy. See what he looks like.
It's totally a function.
Oh, I don't know. I don't know about that spot right there.
It looks like it's. It doesn't. It looks.
Maybe. Anyway, let's just call it a relation.
Okay.
You could do this, right? So you could move all the y's to one side, or you could just differentiate right there, right? But that's good. I'm assuming you solved this out correctly.
I'm assuming that too. I don't know.
2y squared minus 5y cubed is equal to negative 3x squared. Negative 3x squared. What?
Oh, I moved x cubed over, so it's negative x cubed.
Why don't you write that then?
Oh,
You should rewrite it before you take the derivative, because here's the problem. You did 5y cubed, you moved it over here, but you didn't take the derivative of it.
sure.
Yeah, so, okay, yeah, so this is actually, whoa, what was that? Slightly messed up. Okay, alright.
That is
Isolate y prime. How, I'm really confused. How did we go from here to here?
I don't know. I probably changed the equation because, like, when I was making the examples, like, that's kind of a weird equation.
So here's the issue. You don't want to subtract these things here. You need to divide here.
Yeah.
So like when you solve for y prime, it's going to be negative 3x squared plus 3 divided
Wait,
by
no,
all
that's
of
not
this.
it. I remember. It's because I just copy and pasted that from the Google Doc and forgot to change it into an
Ooh,
equation or
okay.
something properly.
What's the 3xy? Like what is this in reference to?
I don't know. I was just trying to. I don't know. X is a constant of y or something. I'm not sure anymore.
Okay, so I would take that out.
Okay.
An equation like this, like what? What is this referring to? Like this thing right here?
I suppose.
Okay, just make it a little more clear, that's all.
Okay.
Okay, 4x cubed y squared minus 7x squared equals 3x squared y plus y cubed. Move all terms with y values to one side. Here's the thing. If you can't move terms with y values to one side, you need to do examples like that. Okay? So like if you have like, I don't know, maybe like cosine of xy plus something, 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 okay? So do an example where you talk about, hey, if you can't move all the y terms to one side, that's fine. You can still take the derivative on both sides with respect to x. You'll get the y primes. Then you need to isolate the y primes. So you want to get all the y primes to one side. 4x cubed y squared minus 3x squared y equals minus y cubed equals 7x squared. Okay, that's good. 12x squared y squared plus 8x cubed y prime minus 6x y minus 3. You might want to be a little more explicit here on this step. Like, why is this a minus here? Because don't we add for the product rule?
Oh yeah, but it's a negative.
What I'm saying is show the step in between where you actually do this, like you minus parentheses product rule. It just helps people understand what's going on here. Minus 3x squared y prime. That's wrong. The derivative of this with respect to x here would be, okay, so it's going to be minus 3x squared y prime.
Yeah.
Just y prime. You have an extra y there.
Okay.
Okay? And then minus 3y squared y prime. That's good. That's good. Okay, yeah, so change that. That's going to change your answer here. So, yeah, so then after this, add one where you can't get all the y's to one side. And then don't forget to, oh, here's the homework. Cool.
And the picture has to move over.
And then, yeah, move the picture over. Cool. All right, so that's 3-7.